Hello taxidermists and gentle peeps, this is Neil Woodman with Digital Taxidermy, and we've got another episode in our series about how to improve your modelling. This episode we're going to take a little look at 3D Builder and see why it's particularly useful for 3D modelers to get your models ready to go out to your customers. So here's a little something that I've been working on. I'm calling it Science Tanks. This is going to be for our industrial section, so keep your eyes out for that. It'll probably appear in our buyers club first, so yeah, check that out and see. So this is pretty much ready for a test print. Been working on it, sorted out a few things. First thing that we're going to do, we've saved it, and we've saved it out into the file system. So we'll get our STL and we're going to drop it into Cura so we can slice it for a test print. Just wait for that to arrive. So you see here the model itself is the wrong orientation, and Mesh Tools is saying that it's not watertight, may not print properly. So this can happen for a few different reasons. If you're using things like Blender, maybe you have multiple bodies inside your model and the meshes are intersecting, which means you don't have a single manifold face. So you've not got just a single edge running around absolutely everything. You'll have faces intersecting and weird stuff going on. Now, Cura doesn't really like that, and the other thing, this is not a user-friendly model. We can't just chuck it in there, we can't just give it to a user, they chuck it into Cura and away it goes. So they would need to do some work on it, and that's not really how we do things around here. As you can see, it does fit the build plate, but if we slice this model, slicey, we'll take a quick look at some of the layer lines, and maybe we'll be able to see some of the places where it is not functioning correctly. So what we're going to do, knowing that this is not watertight and not perfect, is that we are going to instead open up the model in 3D Builder. So when you double click your STL, if you've got this set as your default thing, so 3D Builder is a program included with Windows 10. It runs on the same sort of basis as a thing called Netfab, which is something that a lot of other people can use. Netfab is an online service that enables you to repair models as well. I like using this because it's available on the computer, it's easy to use, plus it has a few other little functions which are quite nice as well. So we import model after selecting the units, which in this case was millimeters. Now, you see you've got this red box around there and it's laying on its back. So we can we get this little dialog box at the bottom here. So it's detected the same thing as Cura. Right, one or more objects are invalidly defined. Click here to repair. This is nice and easy. And so it will run through the repair cycle, and in that it will look for intersecting faces, bodies that are passing through each other, and it will then connect them up. And depending on how your software that you create the model in works, it will also redefine some of the vertices in the STL file. So, for example, if you created your model in SketchUp, you define a lot of the vertices yourself. and similarly in Blender as well. These do create their own patterns of vertices required for STLs, but they're not always like a perfect representation of what you need to take that directly to a 3D printer. So this reads all of them, finds out which vertices are not connected, adds in missing ones, and in general solves 90% of your problems. Once you've run it through here, obviously you slice it in Cura, and then you can check all the layers and make sure that you haven't got something weird going on with any of the bodies post fixing, because that can be a thing. And if so, then you need to look a bit deeper into that. But as I say, this will cure about 95% of your issues just by pressing the repair button. Depending on how large the file is, how complicated the shapes are, and how many vertices or intersecting faces, it can take longer or shorter. This is a fairly complicated model, and there's a few parts in it that have multiple bodies, so I'm kind of expecting several intersections. So we can see in this bit here, these are all separate bodies. And the same with this bit here, so it's trying to find the vertices that intersect them. We can turn on the wireframe here, so we can get a view of where all those vertices are. As you can see, there's a lot down here, and Cura is 3D Builder is just going through and making sure that each vertex attaches to a vertice. When that happens, it is considered manifold, and then you will have a single continuous skin that follows all the way around it. Now this can be made more complex. Again, you can see how your curves generate a much higher concentration of vertices. There's a lot more points to make up as opposed to flat areas like this, or if we go underneath. So you get a good idea here where each of these points needs to be connected to the next to section out an area into triangles, because STLs work purely on triangles, which is quite interesting because a lot of modeling programs model in squares, but when you export it, it turns it into triangles. So there we go, we've done the repair cycle, and that is going to be pretty good, I'm sure. Now we can use the rotation feature to stand it up to make it the right way up. Now, interestingly enough, if you click on these, you can roll it around wherever you like. If you move your cursor onto the inside, then it will snap to 90, 180 and everything. But if you bring it back out, there's no snap. So we can snap like that. Okay. We can also control the pitch, roll and yaw by double clicking and typing in manually if you want to get a specific angle. So that's quite a nice feature. The other thing that you can do, which is very nice, is you can get your object. If you click on object and you have your item selected and then you click settle, then it will put it so that the base is on the X and Y plane, and it will roll it until it meets a point of balance, so on the biggest flat plane that it meets. So we've settled it there. Let me just accentuate it a little bit and you'll be able to see. So if I tilt it like that, you'll see it hits the corner and then uses its center of gravity to find the point at which it will settle. What can happen when it does that, you see it's put the yaw off by just a little bit, so we can put that back to 0. Here is your positioning command, so we can X0, Y0, and the Z height, actually tends to get recorded from the center point in the model. So again, we'll just settle that, and you'll see that Z height is still there. This is your scale feature. You can lock scaling. You can scale the different length, width and height to whatever number you want. So if you're trying to make any alterations to a model, you can do that in there, or you can percentage scale it, which is a handy feature as well. So you can increase its percentage by whatever it is you want. So you can use that with our scale calculators, which you can find on our website, to be able to rescale items to whatever it is you like. You have this function here which allows you to mirror the object, so that just flips it about one of the axes. So if you select the different axes, then you can mirror it around that as well. We also, and this is where you get into some of the modeling features. So similar to like Tinkercad, if anybody has used that, you can do modeling using primitives, which are cubes, cylinders, pyramids, all of these different lovely things up here. And you can drop one of these into your model, and then you can size it, you can move it, you can rescale it, you can rotate it and do whatever there, and you can build up lots of them to create very simple shapes. It's not something I tend to do a huge amount of because I use other programs, but it is there as a functionality, and I do use quite often things like cubes or cylinders to cut out areas of things, which we can do using edit here. So in the edit you can use subtract, so we select the item that we want to subtract from the other, and it will go and cut out a hollow in a second of exactly the shape that's intersecting the model, and then it will heal it up as well. So you can use that to do a bunch of different stuff. You're not just limited to using these primitives. You can actually import another STL and use that to subtract one STL from the other, or you can merge two STLs, so you can do things like kit bashing. So if you've got a bunch of models from, say, Thingiverse, or say you've created a library of Greeblies and assets, then you can actually bring them all into 3D Builder and use them to create another model out of all those bits. And then when you're happy with where they're all positioned, see, there you go. So it's done that, and it's just chopped out that thing. So just get that back, and we'll delete that. So we're back to normal. So yeah, merge as well. You can bring in lots of STLs, kit bash them into one part, and click merge. The other thing that's quite interesting is, so say you want to cut out a small section of something. So we want to get this little box and make that all by itself. So we'll just make that so that it covers that box, and then object, we will select both of those and edit, and we'll intersect. And if I have got this right, there we go. So it will get rid of everything else apart from what was in the intersection of those two shapes. So we can undo all that, that's no problem. The other handy thing that you've got is emboss. So you can use this to be able to put text on things. So again, I've actually used my modeling program to put text on those towers, but you can do it in 3D Builder. So we could put it on here and say we want to put DT for Digital Taxidermy. So we've got that. We can choose a font, and then we can choose how far out or in you want it to be, and then we can emboss that, and it will cut that into. Now this will actually probably go through the model because the model has only got thin walls. So there we go. No, it didn't. It moved it right. It just pushed it in. So there you go. So you can use that to emboss text on curved or flat spaces, which is a very handy feature. Undo. Yeah, there we go. So that's gone. Okay, the next feature that's really handy. So say you've got a file which is very large, you know, so say several hundred megabytes, and you've done it for super high detail. You can use this feature, which is simplify. So at reduction level of 0, with most models you can get away with going to a level of 3, and you'll see what it thins out the mesh. You see how it's reduced the poly count in some of these places. So it hasn't actually done it on this one. I think this is already about as simple as we're going to be able to get it. So, not a great example, this one, because it looks like SolidWorks has been particularly reserved in what it has done to maintain the level. But for a majority of cases, you will find that you can simplify the model down by chucking it into 3, and it will reduce the number of faces in there, and that will reduce your poly count, which will reduce your file size in turn. Smoothing as well, so this will effectively round off corners, but it will do it, it will apply it to everything. So it will, you can alter your smoothness to sharpen or round off corners on your entire model. So a good example of this would be if you've made a model in SketchUp, which doesn't particularly, it's not particularly easy to do fillets and round shapes, not as much as certain other 3D modeling softwares. So you could make something in SketchUp, or you could make something out of very pointy primitives in 3D Builder, and then you apply a smoothness modifier and smooth edges and stuff, and then you'll round things off, which could give you the desired effect that you're going for. The next handy thing is the split tool. So this just allows you to do a plane cut, which, as you can see, it gives you a plane here. You can move that around and you can slice the model anywhere down those. You can flip the side that it takes, or you can keep both. So in that case, we can split the model like that, and then you've got, if we deselect, there you go, you've got 2 separate ones, and you can use this to chop bits off of things, or slice at a level so that you can cut them up for further printing. So we'll just get rid of that, go back, there we go. So those are pretty handy features. The next one that's really quite useful is hollowing. So you can use this if you're preparing stuff for resin printing, which things need to be hollow. Again, I've actually modeled this with particular thin walls, but what you could do, for example, if you haven't been able to do that in your modeling software, is to bring an item into here, select it, hollow it, and then just cut a shape out at the bottom, and then you will have a model that has a continuous skin of a given thickness. So if we go into this, then you can set the minimum wall thickness to whatever it is that you want, and it will go through and calculate that, but it will do it in a kind of, the inside will all be little squares, so it doesn't give a smooth path. It doesn't just take this outer skin, if it was a circle there, it doesn't take the outer skin and compress it inwards to give you the thin wall. It recreates it in a series of voxels, which is squares made out of a series of vertices. So you won't end up with something, a smooth grain circle like this on the inside. It can be a bit jagged. But it's definitely an easy way to thin wall almost any model, if you need to, if you can't manage it inside your own modeling software. And that's the key features that this actually gives you. Once you've done messing around with that, so in this example, we've done it so we can orient this model, and then we're going to settle it, and we've fixed it. So we'll click save. So we save that model. So we'll take the fixed model and we'll drop that into Cura. And there we go. So it's the right scale, and it is in the correct orientation for printing, and Cura is no longer showing the error that it is not watertight. So that would now, pending a good test print, be ready to pack up, be considered verified, and be ready for release. Obviously, so what I'm doing now is just giving it a little slice, so that will take us to the next step in the quality control process, where we'll just take a little look and see how bad some of these overhangs are, see if I need to give the model some more attention in the main software, and then it will go off for a test print, see the results of that, and correct any printing errors that we see, and we'll go through the process again. So once the corrections are done in the modeling software, it will get exported to STL, put into 3D Builder again, orientated, select the correct units, and then checked again in Cura. So anyway, I hope that's kind of given you an insight into why this free piece of software that you get with Windows 10 included with Windows 10, you may find that it's not in your programs list. You have to get it from the App Store now. It used to be included by default, and so you can go to the App Store, pick this up. It's totally free. You can use it for all sorts of different things. It's not that great for doing renders, but it does give you the opportunity to have a look at your model in a 3D space. So analyzing it with the wireframe. You can also show your grid in here as well. There's a few different settings for that, depending on what I'm doing, depends on which setting I'm using. You can also use an X-ray view. Don't tend to use that one, but the wireframe is very handy. And down this side as well, this is where you can control your groups. So if you've put a model in that has multiple bodies, you can group or ungroup them from there. If you've got them in a group, you can merge them, and then that makes them all a single body. Otherwise, you can still actually pull them apart in the STL. So there you go. I hope that's given you a good bit of insight into what this is for and how to use it, and also gives you a bit of insight as to why you would want to run pretty much any STL from an unknown source. So something from Thingiverse. To be honest, even a lot of creators, especially new creators, have missed this step. And if you pull a model into 3D Builder prior to putting it in Cura, you will quite often find it needs some repairs. So drop all your STLs into 3D Builder before you use them. Just make sure that you're going to get the best print possible, because those little non-manifold errors, or if you put it into Cura and it says that the model isn't watertight anymore, those are all things that you can fix really easily inside 3D Builder. You can do it yourself, it's no problems. Cool. Well, that about wraps up this little tutorial. We'll be back with a bunch more things. We've got a whole load of things lined up. If you like this, leave a note in the comments. I'd really like to know where you want me to go with these. If there's any aspects of modeling you would like me to cover, anything you would like me to review, then let me know in the comments below. Don't forget to like and subscribe, ring that bell. Your support will help make the channel grow. In the meantime, we've got a lot going on. Check it all out at digitaltaxidermy.co.uk. We've even got the Digital Taxidermy Buyers Club, which you can find on the website as well. That's over on Patreon, where each month we're doing bundles of files for a massively discounted rate. It will also get you into our Discord server, and that will allow you to chat with us. We can cover topics and questions on modeling. We're there for support and help on general 3D print issues. You can also choose the contents of the next bundle. So we hope to see you over there. Again, that's fairly new as well, so any feedback on any of these things is really good. You'll help shape the future of digital taxidermy. And that's it for today, folks. So see you then. Have fun. Goodbye.
Like the video, follow me around. Press the bell, it makes no sound. Like the video, press subscribe. I don't know why I am alive.